So here's a second example of balancing a redox reaction in an acidic solution. So hopefully you saw the first video. So here I'll go ahead and just go through the motions. Make sure you have your notes in front of you so you can follow along with the steps. So we want to balance the redox reaction. Let's first identify the species that are related. So clearly the nitrogen species are related. And in my second half reaction, the iron species are related. So I'm going to split those up into two half reactions. Remember, give yourself some space because we might have to go in there and write some things down. Okay, so let's go to the first half reaction. Let's balance the atoms other than oxygen and hydrogen. There's one nitrogen and one nitrogen, so that's okay. Nothing to balance there. Let's balance the oxygen atoms using water. On the reactant side, there's two oxygen atoms. On the product side, there are none. So on the product side, I'm going to add 2 mole of water. Now the oxygen atoms balance. 2 oxygens on either side. Let's balance the hydrogen now. Now be careful here. There's 2 waters, so that's 4 hydrogen. But we also have 3 hydrogen on the ammonia. So 4 and 3, that's going to give us 7 hydrogen. Okay, last thing we want to do is balance the charges. On the product side, this is pretty straightforward. Ammonia has no charge, water has no charge, so this is a 0 charge. And so we want to match the 0 charge over on the reactant side. 7 mole of hydrogen plus, so that's 7 positive charges. 1 mole of the nitrite, negative. So 7 positives, 1 negative, that gives us 6 positives. And so we want 0 charge. So we're going to add electrons here. Remember, we always go to the higher charge, plus 6. This side is 0. So we want to go to the higher charge and add electrons so that we can get down to what we're looking for. This side is 0. So we're going to add 6 electrons. And that's it for the first half reaction. Plus 6 minus 6 electrons, of course, gives us 0. Okay, next. Second half reaction. Let's balance the iron first. That's already balanced. Let's balance the oxygen using water. There's 2 oxygen here, so we'll add 2 water. Now let's balance the hydrogen. 2 times 2 is 4. So we're going to add 4 hydrogen to the product side. Okay, now let's balance the charges. Iron is a solid, so this is pure iron, no charge. Water has no charge. So here's another example where you have 0 charge here. So we want to match the 0 charge over on the product side. 4 hydrogen, that's 4 positive. 1 negative charge, that's 3 positive, right? 4 positive and a negative is 3 positive. So we're going to add 3 electrons to balance those charges. So now here you've got 2 half reactions that are balanced. Before we add these together, check those electrons. Over here, the iron is losing 3 electrons. Over here, the nitrite is gaining 6 electrons. That doesn't add up. So we need to balance the electrons before we add these together. So what do we have here? Let's multiply everything by 2 for the second half. So let me rewrite that just to clean it up. 2 iron, 4 water, 2 of this FeO2 negative, 8 hydrogen, and 6 electrons. So now, if you forgive me, let me cross that out. So don't look at that. So now we have this part here, the balanced equation that has us balance the electrons. Okay, now you'll notice a little bit different than our first example in the first video. Now we have a couple of other things going on here. As we add these together, you'll notice that we got water on the product side. Here we have water on the reactant side. So some of these waters are going to cancel. So notice 2 waters here will cancel 2 waters on the reactant side. So the net means what's left over, there's actually 2 waters here. What else do you notice? We have hydrogens. There's 7 hydrogens, but in the second half reaction, you have 8 hydrogen atoms. So 7 hydrogens here will cancel 7 hydrogens here. So the net is just 1 hydrogen. So let's put this together now. 1 mole of NO, 2 moles of iron solid, 2 moles of water, those are these waters that were left over, 1 mole of ammonia, 2 moles of the iron oxide ion, and 1 mole of the H+. Okay, just to recap here, the nitrite gains electrons, so the nitrite's reduced. It's the oxidizing agent. The iron is oxidized. It loses electrons. The oxidized species is the reducing agent.